is not another Pandas tutorial. This is how Pandas is actually used by professionals in real companies every single day. Over the series, we have mastered powerful tools, chaining, GroupBy, merging, apply, Windows function, and more. But knowing syntax is not enough. In real jobs, whether you are an analyst or a data scientist or manager, the question is never do you know GroupBy? It's not the question. The real question is, can you take messy, untrusted data and deliver trustworthy insights that leads to better decisions? So this is how the question will be. Will we really work? This final part answers that question. We are not to follow the exact workflow senior people use on real projects. No shortcuts, no skipping steps. Okay. We are going to follow the exact workflow. By the end, you will have a complete mental model for tuning raw CSV file into business impact. And today, you will learn how professionals structured every senior analysis in 6 stages of framework, how to catch and kill the client bugs that ruin reports, and how to go beyond numbers to stories and recommendations that actually get acted on. So now let's dive in. Okay, so almost every high quality Pandas projects follow these 6 stages in this exact order. So for us, we are also following the same. The 6 stages are injection and health check, which is our primary step. So I'm providing it here, so you can also go through. So here you can see this. Sanitization, type and memory optimization, feature engineering, deep aggregation plus exploration, validation, visualization, delivery, and recommendation. So we never skip. Skipping leads to wrong decisions and lost credibility. So we are not going to skip it. So take this into mind because it's the necessary step we should took as a real data analyst. Okay. Now we can start with injection and health check. Never trust data until you prove it's usable. Okay. So first of all, we need to import some of the libraries, which are definitely import Pandas SPED and import NumPy NP. We need import matplotlib.pyplot as PLT, import cbon as SNS. Okay. Afterwards, we are placing TF equals pd.read data, read CSV. Before that, we need to import our CSV file. Okay. So now we imported our CSV file. Okay. Now we need to call it here HR Employee Attrition. Okay. So this is our primary step. We do all this. Also, we are giving low memory as false. Now run. So Panda sometimes reads files in chunks and guesses the types on the fly. Okay. So that can fail large datas and lead to silent errors like wrong calculations or crash later. Okay. That's why we use low memory here. Pandas may not take the strings as strings or skip files. So the low memory forces pandas to read the whole file first and decide types correctly. In production, this is almost always safer. Okay. And as we know, why we need NumPy, Matplotlib, Seaborn. As we have numerical data, so we definitely need NumPy. And for visualization, we take the help of Matplotlib and Seaborn. Okay, this helps us to visualize our plot. Okay. Now we are moving to the shape. We do know the shape, but if it's a new data set, we may not know its shape or the informations. So we are going to do print shape, and we use df.shape. Then now we get the shape. Now we need the information of our dataset. For that, df.info, add memory usages, deep, okay, place it in a quotation. Yeah, unwanted spacing is not needed, okay. And we are using df.isna, which is dot sum with sort values in ascending order. No, descending order. So we give false here. And afterwards, df.unique. We need to place a n, and then sort values in descending order. So ascending equals false. Okay. Now let's talk about it. Okay, how do we get the error? First of all, we need to understand why we get this error. Okay. So while we go through this code, we can understand it's because the name error or a attribute error. We get an attribute error because there is no attribute named n unique. So what's the reason? The reason is here we used un and I is also there. Now we can get, so this is the correct spelling. So we get the information, the shape, the first it print the shape, then it print the information, then is now, and n unique, all this. Okay, so memory usage deep. Yesterday we discussed about that, but as a refresh, the deep shows true memory cost. Strings are very expensive, so it should show everything. It should show whether it's string, whether it's numeric values. Anyway, it should go deeper and find everything. Okay, find every memory values without changing anything. And cardinality, that is n unique, reveals high cardinality traps like IDs, free test fields that waste memory and slow everything down. So that's why we use n unique here. So to talk more about our n unique and ISNA, we didn't use this code or the syntax anywhere, but we should know what is n unique. That is number of unique values or unique counts. Okay, so while we use this syntax, what happened? It counts the items which are distinct, ignoring all the duplicates, which will give you the precise items or the distinct items. Okay, so the cardinality I talked before is like some fancy data word used in our pandas. Okay, that's nothing to worry about. When we say about high cardinality and low cardinality, while people say that, that means like if there are many unique values in a column, we say like high cardinality, like user ID. User ID has a high cardinality. Email, it has distinct number of emails and user ID. So it has the high cardinality. And while we talk about low cardinality, it's like few unique values like gender. Gender has female, male, transgender, transsexual, all such kind of. Okay. So there are high cardinality and low cardinality. So because of that, we use n unique. Okay. And while we talk about our ISNA, while in pandas we use is null. You know why we use is null? Because to get null values, if there are any missing data or missing values, to check it. So isna and is null is identical, but while our programming get modeled, it just give another word. Okay, so nothing complex. Okay, no confusions. Isna is for showing that missing values, none, nan, or such values. If there is no values, we will get that. Okay. And then while we use sum and sort values, the highest missing value will be in the first position. Like it's in a descending order. So highest will be in the first and then lowest will be in the last. Okay. And it shows the sum of all the missing values in that column. Okay. how many missing value is there or not. And here you can also see that the missing values are taken as, if that value is missing, it will be taken as true, and if there is a valid value, it will be taken as false. Also, to make it clear, the true count as 1 and false count as 0. Okay, so hope everything is clear. So in a line, the ISNA is for as a missing value detector, and we can take our n unique, that is a number of unique, can take it as gets unique counts from every column. Okay, now we should do all these steps, the currently done steps, in the first 60 seconds of our project, because it will save our hours while we do it continuously, while doing other syntax, while working on this data set. Because when we know if there are two missing values, we can sort it in a simple way. But if we didn't know what's missing, was missing, that will collapse or crashes our project. Okay. Now we are moving to sanitization. Okay. First of all, we do injection and health checkup. So if I want to mention that, I will do it. We can we can use a one hash to get a large size or three of it and place this. Okay. And now we are going to do the sanitization. And we can mention this here. So, as we know, sanitization will eliminate invisible killers before they destroy our work. Okay. For that, I'm using df and drop duplicate. Df equals, we are using df dot drop duplicates. Okay, then run. The duplicates quietly inflate every metric counts, rates, averages. One extra row can flip a decision, remove them early. Okay. So this will help us to remove all the things that gonna crash our project. Okay. For that, we use drop duplicates. So we are using drop duplicate here, and as you know, it works like it compares the row and it check whether any extra entries are here or not. Also, it go through the first occurrence and keep the first one as it is and delete the rest extra occurrence. Okay, that's how our drop duplicate works. It scan and find identical rows, then it just um delete it or remove it. Okay, and keep the first one. Okay, yes, we know that, right? So drop duplicate always place the first occurrence and find and remove the rest. Okay, so that's how it works. Now we are going to clean our dataset. That's white space and test cleaning, which is one of the silent bugs that occur in our data. For that, I'm using object with poll equals df dot select dtypes include equals object and then dot poll columns who fall in object calls df poll equals df poll dot str dot strip. Okay, so we just placed calls here, we don't want calls. So if there is two s and s, okay, so we take if we take yes and or if we take yes. Okay, in our eyes, it's just same. It's just 2s. the same words, same quotation marks, everything is same. But while we are doing in pandas take it as different. Okay, so it's not identical like us. I mean, these S and S are different to pandas, but identical to humans. As we are humans, we take it as same, but pandas don't. Okay, white spaces breaks group by filters, mergers. Okay, so in such conditions, we need str.strip, which kills the class of bugs in one line. Do it on all the string columns nearly, because most string columns has white spaces, which will ruin our code. Okay, so in the early stage itself, remove the bugs and make it our initial step. Okay, now we are moving to type and memory optimization. So providing it also, is it a bit large one, because it's given in full caps. Let it be. Okay, now we are going to make our code fast and scalable. For that, what I'm going to do, cat calls equals, we are placing attrition, then comma business travel, then department, educational field, mm, and we can add gender, job role, marital status. Okay, so all these are inside our data set. I'm just not building it. It's all inside. Mm, okay, let's split it so it can be seen easily. Okay, we don't want lengthier lines. Now, what we are gonna do? We need to call the cat calls and make the as type as category. Okay, so we are using our O colon cat calls. We need if call, which is equals to df call dot as type, and then place cat category. Okay, educational field, let's look if it's educational field or it's education field. Okay, so attribute error, key error. Okay, we got a key error. So now it's run properly. Okay, now we know, as we know that category data type store repeater strings as integers code internally, like database lookup. So this helps us to reduce the memory and make our data clean. Okay, the real benefits are like 50 to 90% memory reduction on test heavy data. Also, it provide much faster group by value counts and filtering. Not only that, but while cleaning, the cleaner output in tables like float and tables, we get much more cleaner outputs. So category is our main syntax, which help us to reduce the memory to up to 90%. Okay. In real data sets, like it's like a greater number of columns and rows will be there, like more than 100K rows. So this is not just optional, it's standard practice. You should use it when it is necessary only. Okay, so in this case we are using this category. Okay, it's one hot one, so it can be used when we have multiple values. Okay, in such cases category can be used. Now we are moving to feature engineering. So can add feature engineering. Sometimes I get so trapped with the engineering spellings and all. Can I do? Okay. So here we're gonna turn the raw data into business signals. Now we're gonna turn our data to business signals. How we're gonna do that? Okay. For that we are calling df attrition, and then it's not just attrition, it's attrition flag. Afterwards, we are taking df attrition flag. I mean attrition dot replace that with yes as 1 and no as 0. Okay, place it in a quotation mark. This 2 and done. Okay, so the test yes or no can't be averaged, so we convert it into 1 or 0 dot mean. So while we use this, it becomes attrition rate instantly. This is one of the most powerful code and most common trick in analytics. So here we do df flag and we placed the replace, also change it to 1 and zeros. It's like becoming the attrition rate. Now we need to make the loops as human readable. So this will help us by coding age group, and we are providing age group equals pd dot cut and df age, comma bins equals 18, 25, 35, 45, 55, 65. Okay, this much. And again, we need something labels equals. We can place 18 to 25, then 25, 26 to 35, then 36 to 45, 46 to 55, then okay, 56 plus, that's 65, all this. And now we are placing right as false. Okay, I will explain this. A comma, then right equals false, closing everything. So afterwards, we need to add the our tenure group. Okay, so df placing tenure group, also adding just like pd dot cut, then we can place df years at company, add bin, bins equals, can add 0 2 5 10 20. Okay, and add np dot inf, and for a visual way of showing this, we can place the bin down, and we need the labels equals like less than 2 year, or less than 2 to 5 year, or less than or just less than 2 year, 2 to 5 year, or 6 to 10 year. And let's give what all are left, 11 to 20 year, and 20-year plus. Okay, and also don't forget to place it in a square bracket. So run this. Um, where do we get the invalid syntax? Find the syntax. We can understand that there are some spacing effects. We didn't want this comma here. Run it again. Spacing is fine. So you may already find the mistake that we placed a dot and we get labels as labels. Okay, so it's correct now. Now we need to know how this pd.cut works. Here our pd.cut works as create the buckets humans understand, like row A's or tenure numbers are hard to interrupt. So dupes make insights land. Okay, so to explain about this, I should say, like, imagine um, if we have a massive list of employees' ages and work years, instead of looking at every single number, we are going to categorize them. Okay, first we call pd.cut. That's our sorting machine. Okay, for age, we are defining our bins. Think of this like uh, dividers in a drawer. We are telling the machines that start at 18, then 25, then 35, and so on. Let's give those sections labels. Instead of technical range, we are slapping a clean sticker on the drawer. Like it says 18 to 25, 36 to 45. So the second part, we are doing the same for tenure. We are using np.info at the end. That stands for infinity, which is just a fancy way of telling the machine if they have been here 20 years or 100 years, put them all in 20 plus buckets. Okay, for that we used np.inf. That's in for infinity. Okay, and just like that, we are turning our messy list of numbers into neat, organized cube that are actually easy to read. So here we get bins. The bins says bins kept our things. It labels where everything is kept, and we do the same here. But we added a np.inf, which says the infinity and is telling the machine that if it's are 20 years or 100 years, put them in a 20 plus bucket. Okay, that's why we use the np.inf. And just like that, we turned everything in organized manner. So as a cheat sheet, we can say like pd.cut act like a slicing data. It sliced data. When it comes to bins, the cut points were one group ends and the next begins. It shows the cut points, bins. And while we come to the labels, it's like human friendly names for those groups. We already make groups in bins and we label it because it will be much more helpful for humans to read and understand. And also here we place the right equals false. This includes the first number, but not the last. Like example, 18 to 24.9, not 25. Okay, 25 won't be counted. That's why we give right as false. So, hope everything is clear. I just say it again. As we know, it's like pd.cut. It cut the data. It sliced the data. Bin will cut the points where group ends and nest begins, while labels will name it so humans can easily read that. And the right false, it's help us to just don't take the last number. If it's 25 is the last, 25 won't be counted. 29 24.9 will be counted. Okay, so hope it's clear. And so now we need to reduce the noise. Okay, for that we are using satisfaction score, tf. Satisfaction equals tf environmental satisfaction. Then we need to add job satisfaction, and then relationship satisfaction. So also we are using dot mean with axis 1. Okay. Where do we get the error? First of all, we need to check relationship satisfaction. Okay, first of all, we need to check if there are any mistakes in our spellings. Okay, we may find environment. Yeah, I'm just not so good at spellings. And okay, first of all, correct the spelling. So here we wrote environment in different way. It's environment. So go to the names here. Let's just copy paste it things. First of all, we can take environment. Sometimes I call environment as environment or and then let's take relationship satisfaction. Then our job satisfaction. So while we code, we should understand that the names clearly, or we can just copy paste. We don't want to go through it a lot. Okay, just don't break our make our brain boom. Okay, so after all, uh, this is how we write our code. So now we checked if there are mistakes in our code, but we placed every numbers correctly, every names correctly, X is also correct. So where is the final issue? So while we are giving more than one column names, we provide it in double square bracket. Okay, so hopefully it will change the issues. So it changed, and as we know, we give axis to go row wise, axis one as row wise, and we combine correlator signals into one strong feature. So less noise, clearer patterns. The thing is, you should know where we need, how we need, when we need. So I took satisfaction here. I know satisfaction is the place I need to reduce the noise. And while we code, we should understand where we really need that. Okay. So definitely we will get a video, or we will explain in this video itself why we take satisfaction here, or we take attrition here, all this. Okay. But as the video is a little bit long enough right now, we don't wanna choose to say it now, but let's discuss some other day. For now, we are moving to deep aggregation and exploration. Okay, so for deep aggregation and exploration, I need to code that summary equals, we are giving df dot GroupBy department. We are providing department comma observed equals true. Then dot azz. We are starting another bracket, placing our employee count equals employee number. And then we need to place attrition. Attrition rates equals attrition flag and mean. Then we need average age. So for age is not necessary. Average income, we need average income equals, for average income we took monthly income dot mean. Then comma, we need a average satisfaction, which is equals to satisfaction score and mean. Okay. So our summary is the whole things we want. Afterwards, we give another comma. We are seeing PZT over time equals over time lambda x equals x, which can as a bit. And after all, we need to round it to 3. And then we need to sort, dot round, dot sort, place ascending as equals false. And then let's display the summary. Okay. So we get a summary, display summary here error. Why? Because it's aligned with this alignation indentation way. So we need to move this display to here. So we get a indentation error. So we understand why we get that error. Okay. Run this. So while we run, it will be fine because we cleared that indentation error. Okay. Run it again. It's just a network issue. So as you see here, we got a another error that's says that the key error and shows satisfaction is not. So while we see here, it's a satisfaction score that's not exist because we placed the name as satisfaction, not the satisfaction score. Because of that, we got the error. So we can take it as a satisfaction score, run it again, then again run this now. So it will be cleared. So while I go through the code, I found out that the attrition is missing. So add the attrition right here, separate it with a comma. And then the other thing is, while having attrition flag, we got a error like the category type does not support attrition as aggregation as mean. Okay, so in this situation, we should treat the attrition flag with we can say like lambda x x, and we need to place it as type equals float. And then we can place x dot as type. So here I need to provide as type dot mean, place it the parentheses, delete the space, run this again, and mention here it as float, run it. Okay, so we get this now, and let's move to our next one. Before that, this is decision grade output. We are not just counting, we are explaining which department are risky, are they underpaid, dissatisfied, or overtime heavy, all this. Also, we debug a lot of errors that happens in our code. So while you also get so many errors, you may get the same errors. So you can also debug by yourself. It's like sometimes the score, the name we labeled might be wrong. It may be the if they take attribute attrition flag as a category, we need to convert it into a float. Then only we can take the mean. And for the monthly income, to get the average income, we take the monthly income and mean. So all these are here now. So we get department, employee count, attrition rate, income rate, satisfaction, all this. Okay. Now the key visual. Okay. We are going to present the key visual. For that, we need SNS, that's Seaborn. We are using SNS dot bar plot. Also data equals summary dot reset index. And we are using a comma, place x equals department, then y equals attrition rate. Okay, we need to give palette as Virdis, then float dot title as attrition rate by department. So add this plot dot show. Before that, we need a plot dot y label. Provide y label as attrition rate. Run this. Okay. Here we get error because we didn't add the reset, and we get a float like this. But as Verdis is not the correct spelling of Palti, you can provide Verdis. So now we get the attrition rate by department. Okay, charts communicate faster and more powerful than tables. Always pair numbers with visuals. Okay, now we are going to validation. So this is our chart that shows our visual. Now we need to do the validation. For that, I'm printing and Sniff Test attrition rate 2 ways. So print main of flag, and we need to provide it with df, df with attrition flag, dot mean, dot round 4, then print value count, df attrition, dot value counts, normalize equals true, dot round as 4. Okay, so this sniff test. Here also we get a error. So let's do the same as change the alpha, I mean the lambda float, because it says it's categorical with data types. So to remove this, we can use our as types here. So in this situation, we can give here we can add dot as type, give it as float, run it again. So now the issue is corrected. Okay, so the sniff test calculate the same thing independently. If they don't match, your analysis is broken. Professionals verify, beginners assume. So be a professional person. We need to go through codes. We can do a last data set, done in the last data set. It's like a real resume projects. Okay. So why do we use the sniff test, which help us to calculate the same thing independently? We want that, okay, and we want to know whether it's match or mismatch. So if it's mismatch, our code is broken. Now we are going to export the analysis. For that, I'm providing df dot to CSV, and we can add cleaned HR attrition CSV. Okay, then provide comma index equals false. Provide the summary to CSV, then attrition summary by depth. Provide attrition summary by depth. We can use small letters. Okay, run it again. Now, notebooks are for you. CSVs, reports, dashboards are for the business. If it's not exported and shared, the work didn't happen. So From this analysis, the biggest drivers are often overtime, huge risk factor, or low satisfaction score, maybe years since last promotions, maybe people didn't get enough promotions after years and years, maybe because of the lower income related to a role. Maybe people get as some IT professionals get 10K per month. So maybe because of that, the attrition rate is increasing. There are so many ways. Okay, then this is how we do our full project. It's end-to-end one. And we can see recommendations for this issue, like reducing the forced overtime, especially in high attrition departments. So it can help to reduce the number of attritions, or prioritize the promotion reviews for employees who are having greater than 2 years without one, who didn't get promotion after working for a long period, or boost the satisfaction through targeted engagements. Okay, single younger employees at risk. So if addressed, companies can realistically cut attrition 10 to 20% in key groups, saving significant hiring and onboarding cost. Okay, so these are the recommendation we found out from the data set that we are worked with HR attrition. Okay, so this workflow demonstrate senior traits like skepticism. We checked health and validated the results. The precision. We fixed invisible bugs before they spread. And also the business focus. We delivered clear recommendations, not just code. We delivered it. Advanced Panda is not about memorizing more methods. It's about responsibly owning the truth in the data and helping the business act on it. We done a great number of codes. It's into when we do all the 6 steps. And when you work with this way, you are no longer learning pandas. You are doing real high impact data analysis. That's the end of the series and the start of a real world impact. We're definitely gonna do this practices based on this, because I believe we need practices for all this. Doing it once won't give you, or will help you to remember all this syntax. Also, when to do it, where to do it, or what to take while going through the code. So we will provide the practice sections, like we will again do this end-to-end pandas this phase, and we will provide the code. We will work on it, and we will understand which column should we take, which rows should we analyze, which code should we use there, how to optimize it well. So we will get all this. So that's all for today, and it's our pandas part 10. We can name it here, Advanced Pandas Part 10. Okay. So that's it. We can, if we want, we can just take the so we may find new columns. Last time we have 35 columns about. Now it's increased to 40 and 170 rows. Okay, so we added some of the columns like attrition flag, age, tenure group, satisfaction score, so on. Okay, so that are the new columns we established to it. And we also, not only we added columns, we run with CSV files or syntax. We debug, we found the errors, we find out where is the error, why it happening, and how can I get through that. All this. Also, we answer the questions that each business holder or the stakeholder want to hear. Okay, so from the data set, we got a data set, we found things, we discovered many of the data. All this is done. So it's really a resume ready project for you. You can place it anywhere in anywhere. Also, you can deploy it in Streamlit. Okay, if you want, you can do that, and I will provide that too as a short video. So you can also go through it and show your HR you've done something great. Many students fail to do. Okay, so that's all for today. I know it's a bit heavy and lengthier one, but hope it will help you in future while doing real end-to-end projects. Okay, see you.